Hey everyone, and welcome. Today, we're going to pull back the curtain on some of the hidden math that powers pretty much everything, from your phone's photo filters to these epic video game graphics. We're going to dive into the world of matrix arithmetic.
So let me kick things off with a question for you. What do your phone's photo filters, a boring work spreadsheet, and the amazing graphics in a video game all have in common? I mean, they seem totally different, right? But what if I told you they all run on the exact same secret mathematical engine?
That's right. They all use something called matrices. And hey, before you click away thinking this is going to be some super complicated abstract math lesson, stick with me. I promise you it's not. At their core, matrices are just an incredibly powerful, but surprisingly simple, way to organize information.
All right, so let's start with the absolute basics. What even is a matrix? Forget the scary-sounding name for a second. Just think of it as a simple grid for holding information.
Okay, the official textbook definition is a rectangular array of numbers arranged in rows and columns. But a much better way to think about it is just as a super organized container for your data. It's kind of like a box with shelves designed to keep all your numbers neat and tidy so we can work with them really easily.
Here's a perfect example. This right here is a 2x3 matrix. And why is it called that? Well, for a super simple reason. It has 2 horizontal rows and 3 vertical columns. We always say the dimensions as rows first, then columns. It's honestly that straightforward.
Okay, so now that we know what a matrix is, how in the world do we add or subtract them? Well, it turns out there's just one single, incredibly important rule you have to remember. I like to call it the golden rule.
And the rule is, well, size matters. It's that simple. To add or subtract matrices, they must have the exact same dimensions. You can add a 2x2 to another 2x2 no problem, but you can't add a 2x2 to a 3x2. The grids just don't line up. It's like trying to fit a square peg in a rectangular hole. It just doesn't work.
With that golden rule locked in, let's actually do some addition. We're going to walk through a real example together, step by step, and you'll see just how, honestly, intuitive this is.
All right, here we go. We've got matrix A and matrix B. So, first things first, do they follow the golden rule? Let's check. Yep, they're both 2x2 matrices, so we are clear for takeoff. Our job is to fill in that result matrix on the right.
The process here is, you're going to love this, it's incredibly simple. You just add the numbers that are in the exact same spot. So for the top left corner, we take the 4 from matrix A and the 2 from matrix B. Add them together, we get 6. And that 6 goes right in the top left of our answer. Now we just do that again for every other spot.
And just like that, we've got our final answer. See? Top right, 8 plus 5, that's 13. Bottom left, 3 plus 6 gets us 9. And bottom right, 1 plus 9 is 10. That's it. You have officially added 2 matrices. Pretty simple, right? It's just element by element addition.
So what about subtraction? Well, if you understood addition, then I've got some great news for you. You already know how to do subtraction. Seriously, it's the exact same logic.
Just take a look at this subtraction example. Same golden rule, right? Both matrices are 2x2, and it's the same process. We just subtract the numbers in the matching spots. 9 minus 3 is 6, 5 minus 1 is 4, and you get the idea. It's the identical process, just with a minus sign instead of a plus.
Okay, so we can add and subtract grids of numbers. Big deal, right? Who cares? But this is the part where it gets really cool. This is where we go from these simple little grids to some really, really big and powerful ideas.
You know, this quote really says it all. The super basic, element-by-element math we just did, that's the foundation. That's the fundamental building block that lets computers handle these incredibly complex problems we throw at them every day. It's all about simplicity enabling complexity.
And trust me, this math is absolutely everywhere. Think about image editing. A picture? That's just a giant matrix of pixel color values. When you blend 2 images, you're literally just adding their matrices together, changing thousands of pixels with one simple command. Or in data analysis, you might add a matrix of January sales to February sales to get a quarterly total, all in a single step.
So the real takeaway here is this. It's not just that we're combining data. The crucial part is that the process is so simple, so predictable, that computers can perform these operations on millions of data points, like all the pixels in 2 high-res photos, all at the exact same time. That's the secret sauce. That's the magic. Simplicity done on a massive scale.
So, we've seen how addition and subtraction can combine and compare data, And that leads to one final, much bigger question. If just adding matrices can blend images together, what kind of powerful things do you think multiplying them could do? Imagine the transformations, the rotations, the scaling. That's where the real magic begins. Thanks for tuning in.